Hello, everyone. You're welcome. And so this is the data analytics part of the free symposium program that was held in Uniben. Of course, you can see the flyer on the screen. All right. So let's go quick what's into the session. But before that, um, all right, just like the link that brought you here, if, if you are seeing this video, then you must be on Quiver Analytics YouTube page. All right, so we kindly appreciate that if you can, we appreciate if you can like our videos and subscribe to this. It is free. Just press subscribe and like the videos here. There are other videos here on the uh, on the channel. All right, so now once, of course, there's a link on the email where you would get these files, free symposium. All right, so where if a link on the email will take you to a Google Cloud folder, and you can download it. When you download it, you have all of these materials in the folder, so you can use it and follow this training. All right, so I have opened them. I have the PDF, so statistical analysis for experimental data in laboratory science, hands-on demonstration by Quiver, and this is the email to get through to Quiver, and this is our WhatsApp number. So now about the data, experimental data set for training, we have the description. The data set simulates measurements collected from 200 patients undergoing a clinical test to evaluate the effect of two different treatments, that's drug A and drug B, on blood glucose level and cholesterol levels. Additional data include age, BMI, and gender. All right, so this is the sample data. The first four: the patient ID, the age of the patient, the gender, male, female, the BMI, the glucose before testing, and the glucose level after testing, the cholesterol level before the drugs, the cholesterol level after, then treatments. This first patient was given drug A, and this second patient was given the third patient was given drug B. All right, and we have group 1, 1, 2. I think there are 3 groups in all. All right, now let me show you the the data in Excel formats. You can see the age, the gender, the BMI, glucose pre, and all. And we have the treatments A and B, and the group 1 and 2. So in all, we have 201. Remember, we have number 1 as the heading, so we have 200 patients for this experiment. All right, now let's go to the SPSS files. I have already entered the data into SPSS, and I'm going to put the description here as well. All right, okay, so now the object what we want to do is to take you through the process of producing a publication worthy data analysis, and not just publication worthy, the procedure of going about your data analytics. So we said here, whatever you want to do, you test for normality. That's one of the first things you do. Then for the scale measurement variables, report the mean. So for the scale variables, you report the mean. That's for the continuous variables. You report the mean, and if non-parametric, a median. If non-parametric, then if it is still parametric, you return the report the standard deviation, standard error, and then histogram. That is when you have scale measurements. Example of scale measurement is the age, the BMI, the glucose pre, the glucose posts, cholesterol pre, cholesterol post, because they are measurements. They are values, they are measurements. So presenting this type of data, you do your mean, you can report median as well, and standard error, standard deviation, and so on. Now, otherwise, if they are nominal or ordinal variables, that's categorical variables, you present your frequency table and just frequency table with your bar charts or pie charts. All right, now explore the averages mean per group among the categorical variables. All right, we would get here later. Now, in this video, the scope is to cover parametric tests, and we have non-parametric tests as well, and there are some other things because of time, we have to this is a lot as well. We have to do something that is applicable to everybody and or majority of people. All right, so we have multiple regression. Then there are non-parametric tests for all of these tests. There are 7 tests that we want to go through. We might not be able to cover it in one video, so I'm going to split the video into 2. So we have one sample t-test, we have the dependent paired sample t-test, the independent sample t-test, the one-way ANOVA, the two-way ANOVA, the Pearson correlation, the multiple regression. And now we ended it by saying that there are non-parametric tests for that non-parametric test equivalent for each of these tests. So what does it mean? Now, all of the tests that has been listed here, they are parametric tests. They are not exclusive. Like, this is not the only parametric test that we have, but these are the frequently used parametric tests. And why are they parametric? They are parametric because it is required that your data is normally distributed, and then you have large sample size, and then there are scale variables, scale measurements like BMI, glucose, all those things I just talked about. So if they are, then you can use parametric tests. Those are the basic assumptions, especially the normality tests, and then big data. Of course, the third one too. All right. So we are saying that for each of these parametric tests, there are equivalent non-parametric tests. Wilcoxon signed rank tests, Mann-Whitney test, Kruskal-Wallis test, Friedman test, Spearman correlation. There is also chi-square tests. All right. So now, if you don't have SPSS, this is a link to download SPSS version 25. It's quite heavy. It's somewhere in the YouTube channel. There's a video on installing SPSS and how to code SPSS. So we are not going to be doing all that here. You can try to look for it in the series of video. Another important thing I need to talk about is we have a program coming up. It's online, and it's a 2-week rigorous SPSS training, and it's online. And you can see the benefits here. We have data entry, data cleaning, and data visualization tests, non-parametric tests, report writing, case studies, blah blah blah, unlimited resources, and so on. And it's just 25,000 naira. The original price is 250,000 naira, but we are putting everybody on a 90% scholarship, 25,000 naira. And you can contact the email above and the phone number above here for registration starts on the 20th of January 2025. All right, so if you are interested and you want to know SPSS further, you can to register. It's simple, just pay into the Money Points corporate account, and you can chat or send an email to verify, to validate your payment. All right, without wasting much time, the first test we want to do is the one sample t test. Now the objective is this: to determine whether the average pre-testing glucose level differs significantly from the population or assumed given mean of 140. All right, now what does this mean? We have a pre-treatment glucose measurement that has been taken. This is the pre-treatment glucose measurement. The pre-treatment glucose measurements. Now, there is probably a standard, for us to go through these experiments, all these measurements and all. There is probably something of concern. We've seen that the glucose level of this population is probably high, 140, and so let's test if truly the average is 140, the mean is 140 or not. So to test that, you will use a one sample t-test, and the corresponding hypothesis is that the null hypothesis is that mean glucose pre-administration of the drugs is 140. The alternate hypothesis is that it is not 140. All right, so quick statistical inference is that if your p-value, whenever you carry out your tests, if your p-value is less than or equal to 0.05, then the test is significant. All right, otherwise the test is not significant. That we cannot trust that result, we cannot trust that test. All right, so that's when carrying out a test at 95% confidence interval. Now let's go straight into that. We'll not just do one sample t-test just like that. There are some pre-testing procedures that we have to do here. So the first thing is test for normality. Let's go to analyze and descriptive statistics, explore. All right, so let's explore the age, the BMI, the glucose, and all the measurements, and putting them in dependent variables. So statistics, okay. Plots, I don't need the stem and leaf plots, I just need the normality plots with tests. All right, options, continue, then give me both. Now the SPSS brings out the outputs window, which gives me where the results are presented. All right, so for age we have mean of 41.57, standard error of 0.970, and 95% confidence interval, 5% trim mean, and so on. Minimum age is 18, maximum is 64, and range blah blah. Skewness and kurtosis important. So for your skewness, a good skewness score should be between plus and minus 1, and a good kurtosis score should be between plus and minus 2. All right, so this is good. BMI as well for normality tests. All right, this is also good, and so on. Let's go check the plots. This is QQ plots. The more the observations surround the diagonal, the better it is, the better we say it is normally distributed. So this is fine, and you can see the okay. I'm interested in the all right, so I don't have the histogram here. I'm going to go back to descriptives, frequencies, and again pick all of this, and statistics, I already have the mean. I have this. I have everything. So I'll just say mean, charts, histogram, and show normality curve. So I don't want the, you don't have to display frequencies. It's a redundant estimate for scale variables. For scale variables, it's a redundant estimate. So I say, okay, what I'm interested in is this charts. You can see the bell curve is still shown. The bell curve is shown in all of them. All right. So to a large extent, we can say that our data is normally distributed, which is fine. Now, the first one is done. That means we can apply normality test, parametric tests. In case where they are not, then we can not apply parametric tests. Although some people still go ahead if they have large data sets, 500, 600, 1000 plus. Now, we want to explore this data more. So we said for the scale variable, report the mean. That's what we've done. The histogram with density plots is what we've done. Now explore the averages, mean per group, the categorical variable, analyze, blah, blah. So let's see. Now among the male, let's see the average age, and among the female, also the average age, the BMI, the average BMI, the average glucose pre and post, and all. So let's go to analyze. Descriptives. No, okay, we are going to means. Where are you? Okay, compare means, then means. All right, so dependent lists, we have age, and let's see by gender. Okay. All right. So for female, you can see for female, for male, the average age, the number of female is 108, and here's the standard deviation. The number for male is 92. So by exploring, we get to know more about the data. It's not possible for us to explore data row by row, column by column. It's large. So it's when we do this sort of exploration, you understand your data better. So female, you have 41, average age is 41.9. For male, average age is 41.13. So on the average, they are like the same thing, but female are quite, we should expect older female population than the male. Then the BMI 26.1, then for male 27. You can check that later. All right. Now, so we've done these three to know what to expect. Now, one sample t test, like we explained earlier, and our mean test mean is 140 for glucose pre. All right. So you go to analyze and compare means. You can see one sample t test here. So the where glucose pre, bring glucose pre here, and then our value, test value is 140. That's all you need to do. Okay, so we have the t. Okay, this is one sample statistics. The n is 200, mean is 149, standard deviation and all. Now here we have the significance to tail is 0.00, is less than 0.05. So we say this test is significant, it can be trusted. If it is significant, then yeah, so it can be trusted. Then we reject the null hypothesis. This null hypothesis is rejected once the p-value is significant. Once the p-value is less than 0.05, we reject the null hypothesis. Just the null hypothesis. Okay, I just wanted to make it okay. So we reject the null hypothesis, and we conclude that mean glucose is not 140. All right, so that is simple one sample t-test. Now the paired sample t-test. Now when to use the paired sample t-test, an example is to test whether there is a significant difference in glucose level before and after treatment. Now, dependent sample t-test. This is a case where you have the same population, the same set of people that you've applied the same thing on, either people or objects or item, that you've applied the same chemical on before. You took the measurement before and then after. So you took the measurement before the intervention, then you took the measurement after the intervention. Nothing has changed. Every other factor remains constant. The environment, temperature, except they are the things you are making use of, except they are your intervention. I mean, yeah, they are the intervention. All right. So now we want to test if there's a significant difference in glucose levels before and after the treatments. Remember, some of them had drug A, drug B, drug A or B. All right. So, however, drug A or B irrespective. That reminds me, we're going to do something just now. Okay, drug A or B irrespective. All right. Now, so we go to analyze, compare means, one sample independent paired sample t-test. Paired sample, the paired sample is also called before and after. And in marketing, if you are from social sciences, in marketing or in business, it's called A/B testing. All right. They are used as common as using Facebook adverts, but this is not a marketing class. To make this video as short as possible. All right, so glucose pre is the first one, then glucose post. That's all you have to do, and okay. So here we have degree. I mean, the significance to be 0.00. Again, it is significant, and it means we reject the null hypothesis, and we do not reject the alternate hypothesis. So we can conclude that according to this sample, mean glucose pre is not equal to mean glucose post. So the fact that they are not equal to doesn't mean, so which one is greater? So that's simple. You can come to the descriptive statistics. For the pre, the mean is 149. For the post, it is 130. So that means glucose level has been significantly reduced from 149 to 130. The difference is significant. There's a significant difference between, that's how we say it, there's a significant difference between glucose pre and glucose post after administering the drugs. Now, one thing I remembered that came to mind is that, this one we did it for both A and B, like irrespective of the drug. So what if we want to compare the differences between the pre and post for A, pre and post for B? All right, that just came to mind, and it's good. So let me show you how to do that. So you can come here. This is split file. It can also be found in data. You see split file here. So compare groups, and you go to treatments, put in your treatments. Your treatment is A and B. So what it does is, whatever analysis you do, it's going to carry it out in those groups. All right, so I'm going to go back to the paired sample t-tests, the recently used dialog, and the same thing. Okay, so you can see among A, pair 1, glucose pre and post, glucose post. Among the B, we have glucose pre and glucose post. It's even gave us a correlation, 3.52 and minus blah blah. The statistics is here. Among those who took A, that's 103 of them. their average glucose before taking treatment A is 151. Their average after taking treatment A is 129. So that's a before and after test, 129.52. All right, so the difference here, is it significant? Again here, the among those who took B, 97 of them, before they took the treatment B, their average glucose level is 147, while after taking the treatment B, their glucose level dropped to 130. All right, so let's see, are these differences significant? So let's just come here. Yeah, so among the treatment A guys, we have it is significant, and here as well it is significant. All right, so that's how to do a comparative test. All right, so I'm going back to the split file and analyze all cases, do not create groups. So to return it back to what it was before. Now independent t-test. So we're going to stop this video after independent t-test, so that the next video we can work on the others. All right, independent t-test compare glucose levels after treatment between drug B and drug B groups. Now the after treatment here, glucose level posts. Is there a difference between A and B? Is there a difference between treatment A and treatment B of the post glucose level after administering A and B? All right, so we go to analyze, compare means, and independent. This is independent sample t-test. All right, independent sample in the fact that there are two different groups. All right, there are two different groups. They are not the same thing. They can be male, female, but under the same umbrella. So like this A and B, they are under the same umbrella treatments, but treatment A is different from treatment B. All right, so we go to treatments, we add it here, define groups, the 1 and 2, because we have two of them. I'm going to show that to you now. So glucose posts, is there a significant difference? And okay, so let me show you the 1 and 2 that I just wrote there. So for treatments, you can see 1 represents A, 2 represent B. All right, so now for the tests we have where is the okay, so now there is no significant difference between the two. That means that we cannot say that treatment B worked better than treatment A, nor can we say that treatment A worked better than treatment B. So after the test, there was no significant difference between A and B. All right, after the test, there was no significant difference between their glucoses, thanks to treatment A and treatment B. Looking at their ordinary mean, we have 129.52, 130.56. So the differences are not much. I mean, the differences is not much at all. The average difference is not much at all. All right, so in the next video we want to talk about one-way ANOVA. Now, one-way and for the independent sample t-test, we are able to carry this out because our groups have two levels, drug A and drug B. Drug A and drug B. All right, once we have more than two levels, say we have drug A, drug B, drug C, we use one-way ANOVA. Like you would see here, we have to categorize the BMI into underweight, normal weight, and overweight. All right, then for two-way ANOVA, okay, so when we get there, we'll talk about this. All right, thank you, and see you in the next video. Don't forget to download your SPSS here. The link is going to be up till maybe February ending, and check the YouTube channel for how to install it, and then don't forget this as well. Hurry, we have a few days to, as if you are watching this on Thursday. We have a few days to Monday, and it will be good for you to join us from the beginning. And if you are joining us halfway, it's still okay, because the classes are recorded and they'll be dropped on the Google Classroom. All right, thank you, and see you in the next video.